In this lesson, we shall focus on Mathematics Paper 1, Grade 11, as it was written in June 2022, and it was out of 100 marks, written in 2 hours. And we actually analyzed the question, solve each question step by step, and see how the kids had to deal with this exam paper in the year 2022. Right, question 1 says, for which values of x is this real? Right, so determine the values of x for which this big radical is real. The real aspect of this appears when we have the expression under the square root sign greater or equal to 0. Real results occur whenever we're taking square roots of numbers that are greater or equal to 0. And that would mean that x plus 3, because the denominator, the x plus 1 whole squared is already greater or equal to 0. That means x is greater or equal to 3, and that means x is greater or equal to minus 3. Any question? But not only that, but also because we have division, each time we have division, we need to restrict the denominator, and we need to say the denominator cannot, x cannot be equal to minus 1. Alternatively, we can write these a bit more detail and say the following. We have that x plus 1. Okay, my other recording is done. That's why this thing is just showing the recording. All right, or alternatively, then you can say that the denominator x plus 1 all squared cannot be 0. Okay, these are very important things for this to be real. The denominator cannot be 0 because we did not divide by 0. So the denominator cannot be 0. And if the denominator cannot be 0, what does it mean? You can take the square root. And so you can take the square root both sides if you want. To remove this to solve for x. Okay, so and therefore this is 0, and if it's not 0, therefore it would mean therefore that at this point you'd have x plus 1, and therefore x is not minus 1 there. X is not minus 1 there. Okay, that's something you can take note of. So either way, then we actually have two conditions. X must be bigger than or equal to minus 3. X is not minus 1. And these are the two conditions for which this is real. Next question. 1.2.1. 1.2.1. Solve for x if this is the case. X plus 4, x minus 1. Okay, what are the values of x here? X is minus 4 or x is 1. Okay, so those are the values of x in the case of 1.2.1. Next question. 1.2.2. We have 3x squared minus 2x equals 14. 3x squared minus 2x minus 14 equals 0. Let's solve for x. Minus b plus or minus the square root of b squared minus 4ac out of 2a. Okay, so it's going to be minus 2 plus or minus the square root of minus 2 squared minus 4a is 3, c is minus 14. All over 2a is 3. Okay. So what then we have is plus or minus. Whatever we have under the square root, so this is going to be exactly the same as the 86. It's going to be 4 times 43 all over 6 2 plus or minus square root of 4 square root of 43 divided by 6. 2 plus or minus square root of 4 is 2 square root of 43 divided by 6. And this you divide, which is 1 plus or minus the square root of 43. You divide by 2, which is 1 plus the square root of 43 or x is 1 minus the square root of 43. Okay, yeah, this one, 1.2.2. All right, we've got the answers there. And obviously you can express this one as decimals. So the top one, for example, is approximately what? The 1 plus square root of 43. X is approximately, the 1 plus is 2.52. Approximately minus 1.85. Okay, yeah. So these are the two answers to the 1.2.2. Once the examiner says correct to two decimal places, you need to make sure that you use the quadratic formula there. Next question. This one of x squared. X squared minus 2x. You let k be x squared. You take the common thing. X squared minus 2x. Let k be x squared minus 2x so that you have k equals 18 minus 45 out of k. Okay. When you get to this point, you multiply everything by the LCD. So the lowest common denominator, if there are fractions like this, because there's a k in the denominator, you can let the LCD, take the LCD to be k. And therefore we have k by k, multiplying each term, 18 by k, 45 over k by k. K squared, 18k minus 45. K squared minus 18k plus 45 equals 0. Factors of 45 that give minus 18 or what? Minus 15 minus 3. Minus 3 equals 0. Minus 15 minus 3, which means k is 15 or k is 3. At this point, x squared minus 2x is 15. X squared minus 2x. X squared minus 2x minus 15 is 0, which means x is minus 5. X is minus 5. Okay, now you get the factors here, and you have a minus 5 and a plus 3 equals 0, which means x is 5 or x is minus 3. Welcome, Tando. And then also you can have the part where k is 3, so you'd have the x squared minus 2x. Okay, equals k, but yeah, k is 3, which means you have x squared minus 2x minus 3 equals 0. And this is going to become x minus 3, x plus 1. These are the factors, giving you x is 3 or x is minus 1. Okay, take note of this. Take note of the solutions here. What are the answers? X is 5, x is minus 3, or x is 3 or x is minus 1. Okay, these are the four roots of the equation in 1.2.3. Next question. Okay, we want to solve this one with a big radical. And therefore, we have 5 minus x, which is minus 1 minus x. You square both left and right. Squaring both left and right removes the square root sign, leaving us with 5 minus x. You square this one, 2x plus x squared. Okay, we collect like terms and, okay. Collecting like terms and adding them up. Adding the like terms up, what do we achieve? 2x plus x, which is 3x. 1 minus 5, which is the minus 4, equals 0. Take note of that. So what are the factors of this? We can do with ease. Factors of x squared are x and x. Two numbers whose product is minus 4, but whose sum is plus 3. They are plus 4 minus 1, giving us x is minus 4, x is 1. Now, if you put x equals 1 into the formula here, you'd have that you have a minus 1 there. Yet this side, yeah, you have a minus 1 if you put x, if you substitute x equal to 1 into this. But simultaneously, there are a couple of things that become very important. So the square root here is positive, and plus 1 is a positive number. So this can't be negative. So this one is out. So alternatively, I mean, you can say x equals 1 is not applicable, and x is only minus 4. Okay, yeah, it's something that you need to take note of. And then we move on to the next question. Okay. Minus 4, if you put it here, you have minus 1 times minus 4, which is a 4. And 1 plus, if you put minus 4 here, is 5 plus minus 4, which is the square root of 5 plus 4. 5 plus 4 is a 9. The square root of 9 is a 3. 3 plus 1 is equal to 4. So this one is correct, but yeah, 1 is out, is not applicable. Okay, so we have solved this problem here by using squaring both sides technique. But also, after squaring both sides, it's very important to check your answers and see if the answers are correct or not. So you continue to solve the next problem, 1.2.5. In 1.2.5, if you have 3 to the power 2x plus 1, minus 4 times 3 to the power x equals minus 1. We need to solve this one. And to solve for x here, a couple of things become very important. We need to always separate. So if there are sums of things at the top, you separate, like 2x 3 to the power 1. Minus 1. Okay, this is plus 1. You bring this across, which is 3 times 3 to the 3 to the power x squared. Okay, the 3 to the power 2x, we can write it 3 to the power x squared. Then we have minus 4 3 to the power x plus 1 equals 0. Using the k method, you let k be 3 to the power x. And if that is the case, then you have 3. Here you have k squared plus 1 equals 0. Okay, let's just solve this quickly. Okay, the factors of this one are, without any waste of time, so we continue. Right, we continue. The factors of 3k squared are 3k and k. And here you have minus 1, minus 1. Okay, so if you check here, if this multiplication is correct, 3k squared minus 3k minus k minus 4k plus 1. K is 1/3. Or k is 1 out of this. Now, you need to recall that k is 3 to the power x, so that wherever is k, you put 3 to the power x, and here it is 3, 1/3 is 3 to the power minus 1. Or here, k is 3 to the power x, so wherever this k, you put k, which is 3 to the power x, and this is 3 to the power 0. Okay, if the bases are the same, because 3 to the power 0 is a 1. If the bases are the same, you equate the exponents, getting x equals 0. Here the bases are the same, and therefore you equate the exponents, getting x equal to minus 1. That's the answer. So next question. In 1.2.6, we need to solve the quadratic, this one. So if you have x squared minus 3x is less equal to 0, factor this out and have x minus 3 is less equal to 0. Okay, so if you have to, because we've already factorized here, we have taken what we call the highest common factor. We find what we call the critical values. Okay, the critical values are 0 together with 3. Okay, plus a positive coefficient of x means you have a minimum vertex, starting with the smallest to the largest, 0 to 3. Right, so you continue. So now if you then say this is less or equal to 0, it is equal, you are equal to 0 here, but less than 0 when you are at the bottom here. So in other words, we can see that the graph is positive here, it is negative here, and the graph is positive there. We're interested in the part which is negative, which is between 0 and 3. So you can jot positive here, it is negative here, it is positive here, like so. So yeah, when you're interested in the part where it is negative, less than 0, the quadratic is negative, is between 0 and 3. So you'd say your answer is between 0 and 3, but inclusive, because this is inclusive of 0. Okay, next point. Right. We continue. Now, we're focusing on part B right now. And part B says if f of x is this quadratic function. So obviously we looked at part where the quadratic is negative, but now if we give the quadratic a name f, of the name f of x, write down the values of x for which the quadratic itself at x minus 3 is negative. So in other words, we looked at f of x equals x squared minus 3x. And then we said this is less equal to 0, and we got x is between 0 and 3. Okay, we did that in the previous question over here. But now let us analyze and see what happens when we are going to look at the next thing. If you have f of x minus 3. So in other words, now we're going to replace every x by minus 3 here. So and that would mean that would have 0 is less equal to x minus 3 less equal to 3. Okay, just replacing every x by x minus 3 in the original expression. And that would therefore mean that at this point, we have what to do here? Would have the following thing. You'd have that we want to solve for x, so we add 3 to both sides of this. Right, adding 3 like this would mean, okay, want to solve for x, and obviously we just replace every x by x minus 3 in this particular inequality we got. Right, so that is 3 is less equal to x, less equal to 6. So yeah, this is exactly what we have. So we move to the next question. So obviously, I mean, that means the answer to B is actually 3 less equal to x less equal to 6. The sum of two numbers is minus 10, and the product of the same numbers is minus 600. Determine the value of the two numbers. Right, so let's look at 1.3. It's a word problem. The sum of two numbers is minus 10. The product of the numbers is minus 600. Determine the value of the two numbers. So let x and y, let x and y be the two numbers. Let x and y be the two numbers. And then you can get their sum in their product. In their product. Like this. Let us get y equals minus that. Call this the first equation. Call this the second equation. So that in the end, what we're then having here, you can take, because the product, what is the product? Product is the result after multiplication. And the sum of the two numbers, the result after addition, when you add them up, you have minus 10. And then now you need to substitute. Substitute equation 1 into equation 2. Equation 1 into equation 2, so that when you get to equation 2, you have x. The y here is minus x minus 10. Minus x squared minus 10x equals minus 600. Okay, now you can move these terms to the across to the right, getting x squared plus 10x minus 600 equals 0. Okay, what are the factors of minus 600 that give 10? You can use the quadratic formula if you're not sure of this one, but you already know what we can get here. X. The factors of x squared become x and x. Okay. Factors of x squared become x, x, and x. And then we have also the factors of minus 600 that give 10. And those are minus 20 and 30. So that in the end, then we have x equals 20 or x equals minus 30. And then obviously we know that, but y is minus x minus 10, so that y is minus x is 20 minus 10 minus 30. Or your y is minus x minus 10, x is minus 30, minus 10. So at this point, what we're then having is y is minus 30 minus 10. Okay, y is minus times minus 30, which is 30 minus 10. What is 30 minus 10? Is 20. So y is 20. What are the two numbers here, as a matter of fact, that the examiner wants? So we're able to see that they are the two numbers. We must find the two numbers whose sum is minus 10. So if you are to take the numbers as x equals 20, y equals minus 30, if you add them up, 20 minus 30 is minus 10. When you multiply them, it's minus 600. We're good. Or you take the two numbers, I'm going to put them in the block. Y is minus 10, y equals 20. Okay. Okay, y is 20 and x is minus 30. X is minus 30. Okay, you're getting x is minus 30 here. X is minus 30 and y is 20. You add them up, minus 30 plus 20, they give you minus 10. But when you multiply minus 30 by 20, you get minus 600. So those are the numbers. So you have those pairs of numbers. X is 20, y is minus 30, or x is minus 30, y is 20. Okay, you add this up, you get minus 10. Add, you get minus 10. Yeah. So you're good. So you solved this problem in detail. Okay, next question. Okay, let's deal with SADs and things like that. These ones we can quickly do without wasting much time. Okay, simplify completely without use of a calculator. How to simplify these? To simplify these, we multiply. The number 8 is 4 by 2. Because 4 is a perfect square, so it's a good choice of numbers under the square root sign. 32. 32 here, it's 16 by 2. And because 16 is what? It's the perfect square. 50. 2 by 25 by 2. Square root of 4, square root of 2, 4. Square root of 16, square root of 2, 3. Square root of 25, square root of 2. Okay. So that you have 2. The square root of 4 is what? Is 2, the square root of 2. The square root of 16 is what? It's exactly 4. Square root of 2. 3. The square root of 25 is a 5. The square root of 2. 2 by 2 is 4. The square root of 2. 4 by 4 is 16. The square root of 2. 3 by 5 is 15. The square root of 2. So if you have 4, the square root of 2 minus 16, the square root of 2, what to achieve here? Okay. 4 minus 16. 4 the square root of 2 minus 16, the square root of 2 is minus 12, the square root of 2 plus 15, the square root of 2, which is exactly what? Minus 12 and 15 would give us exactly 3, the square root of 2. And this is the answer. So, okay, this one is under sets and radicals. So we have the radical expressions and able to get the answer there to this question here. So we continue and solve a little bit more problems as we move forward. Right, so we try now to do the next question. 2.1.2. Right, 2.1.2, you need to simplify completely without use of a calculator if you have this one here, which is 3 to the minus 1/2. And we have the open square bracket. The 12 is 4 by 3. And this one becomes the cube root of 3 times 1/2. 3 times 3 to the 1/2. Okay, so this one here is the square root of 4, square root of 3. This one here you can write as 3 to the power. You see, if 3 to the power 1, 3 to the power 1/2, you can write it as 3 to the power 1 plus 1/2, which is 3 over 2. And this one is like a cube root. So the cube root is 1/3. Okay, now this one is 3 to the minus 1/2. Square root of 4 gives us a 2. This 3 can bring us 3 to the 1/2. 3 cancels 3, giving us 3 to the 1/2. Okay, now you are multiplied by 3 to the minus 1/2, which is 2 times 3 to the minus 1/2 plus 1/2, 3 to the minus 1/2 plus 1/2. 2 times 3 to the minus 1/2 plus 1/2 is 0. 3 to the 0. 2 times 3 to the 0. What is 3 to the 0? 3 to the 0 is a 1. Okay, so 3 to the 0. 3 to the 0 is a 1, but you add a 1, and 2 plus 1 is a 3. Take note of that and make sure you understand. Okay, so the answer is 3 to this particular static equation. We move to the next question. The next question involves higher powers, so you need to make sure you understand these, what to do with the higher powers. But the examiner saying you need to simplify completely without the use of a calculator. So the use of a calculator is prohibited here. And what do we do? So if you have 5 to the power 2006, 5 to the power 2004, 24 all over 5 to the power 2004 plus 1. Okay, you need to simplify this thing here, but please without use of a calculator. So we can take out the highest common factor out of the two terms in the numerator. The highest common factor is 5 to the power 2004. And this one is 2000 6, so 2006 is 4 plus 2. 6 is 4 plus 2. So it means that you can put a 2 there. Okay, let me write a bit more steps. Which is 5 to the power 2004 times 5 to the power 2002. 5 to the power 2004 plus 24 divided by 5 to the power 2004 plus 1. Okay, because now this is 2006, you can add the powers 4 plus 2, 6. Let's take out the highest common factor, 5 to the power 2004, and then we have 5 squared minus 1 plus 24, and all this here is divided by 5 to the power 2004 plus 1. Okay, what is 5 squared minus 1? 5 squared is 25 minus 1 is a 24, so this gives us 5 to the power 2004, and it is multiplied by 24 plus 24 all over 5 to the power 2004 plus 1. So, what do we get? We have 24, which is 5 to the power 2004 plus 1 divided by 5 to the power 2004 plus 1. You cancel this out and you get a 24. So the answer is clearly 24 there. So obviously we have simplified this completely. And if you have a question, please let us know if there's any question there. No question. Right, so we move to the next question. This one is about the radicals, and let's deal with the radicals with much ease and simplicity. So now they're saying write x squared in terms of x. Okay, so this is exactly that. So obviously what we have is that x itself is the square root of 6 plus the square root of 6 plus the square root of 6. Okay, to 4 plus the square root of 6. So you square both sides. Okay, so you'd have 1, 2, 3, 4, 2, 4. And then you square everything. So if you get x squared here, if you square the square is going to remove the outermost square root, leaving us with 6 plus 6 plus 6. And in the end, then you have this 6 plus 6 plus 6. Can even add another 6 there. So these are like continued radicals, and you have x squared equals 6 plus. Now, this 6 plus 6, the square roots like that, they are all equal to x. And this means x squared is 6 plus x, and this means x squared minus x minus 6 equals 0. Take note of that. X squared minus x minus 6 equals 0. Okay. All right. So obviously, I mean, the first question was determine write x as in that form in terms of x, write x squared in terms of x. So the answer will be that x squared is 6 plus x. I mean, that would just be the answer. And this is very, very enough. Can stop here at this point. Noting that x squared is 6 plus x, so we'll write it like that, and we'll stop there. Let's get to the next point. In 2.2.2 now, we already know that x squared is 6 plus x. I mean, that is what we wrote. We got here, x squared is 6 plus x. But in the next question, we need to hence determine the value of x, which is x squared minus x minus 6. X squared minus x minus 6 equals 0, and we determine the value of x. So the factors are x minus 3x plus 2 equals 0. Let's take a look at these, reason together, and see what we're able to achieve. But we're able to see that x is 3 or x is minus 2. Okay, pay attention to these and realize that these square roots, these x is a continuation of square roots. These are like continuous radicals. So at which point, therefore, x cannot be a negative number because the square roots are themselves positive, meaning x can only be 3, and 3 is the answer to the question. In the next point, We are trying to deal with this rectangle, and given rectangle PQRS and QR is the square root of 8 minus 1 and RS is the square root of 8 plus 1, determine the length of any diagonal of rectangle PQRS. So we want to find the length of any diagonal. It can either be this diagonal or that. A diagonal is actually a line segment that runs from the vertex of a shape to the opposite vertex. Okay, so this is what constitutes a diagonal. At this point, we want to determine the length of any diagonal of rectangle PQRS. So how do we proceed to find the diagonal there? We proceed as follows. What do we then do with the diagonal? We find the diagonal as follows. Right, so, I mean, you already know this one is the square root of 8 plus 1, the square root of 8 minus 1. And we'll then proceed to find the diagonal, which means that you have d squared. You have d squared here, and this, if this is d, the diagonal, so you'd have d squared equals the square root of 8 plus 1 squared plus the square root of 8 minus 1. You also square this, and this is d squared. You square this, which is 8 plus 2 to the square root of 8 plus 1, and then you square this one is 8 minus 2 to the square root of 8 plus 1. D squared, which is this. 8 plus 8 is 16. 16 plus 2 is actually 18. So we have d squared equals 18 and d squared equals 18. You find the square root, which means d equals 9 by 2, square root of 9, square root of 2, 3 the square root of 2 equals d. Okay, leave your answer in simplest set form, which is 3 the square root of 2 units. 3 the square root of 2 units. 3 the square root of 2 units. And obviously at this point, you need to determine the length of any diagonal. So the diagonal would have to be SQ, for instance, is 3 the square root of 2 units. So 3 the square root of 2 units is the length of any diagonal of the shape. The next question. So yeah, we're done with that one. And yeah, it's diagonal, we can find this. But remember, this is a rectangle, so you can tell the examiner opposite sides of a rectangle are equal to each other. If they are, this one is the square root of 8 minus 1, and also this one is square root of 8 plus 1. And obviously, I mean, you can find the diagonal. We find the diagonal SQ. You can also find the diagonal PR. PR, because you already know this vertical one, you can call it Y, and the horizontal one you can call X. You can use Pythagoras theorem, x squared plus y squared equals r squared, but we've already got the answer here. But there are many ways to get the answer. The next question. I would be interested in looking at this one and saying, okay, now the first 4 terms of a quadratic pattern are -7, 0, 9, 20. Determine a formula to represent the general term of the pattern. So let's find a formula to represent the general term of the pattern if this is basically a quadratic pattern. So you'd have -7, 0, 9, 20. 0 minus into minus 7 is 7. 9 minus 0 is that. 20 minus 9 is 11. 9 minus 7 is a 2. 11 minus 9 is a 2. 2a equals 2. 3a plus b equals 7. A plus b plus c equals this. So if 2a equals 2, you divide both left and right by 2, getting a equals 1. Okay, after having obtained a equals 1, this is true with the fact that 3a plus b. Okay, remember we're dealing with the quadratic number pattern. So 3a plus b equals the first term of the first differences. These are the first differences. These are the second differences. So what then we have is 3a plus b is 7, which is 3 by 1 plus b equals 7, which means b equals 4. Having found b equals 4, you have a plus b plus c equals -7. A equals 1, B equals 4, plus C equals -7, C equals -7 minus 5. Okay, because the 1 plus 4 is a 5. So that now this is minus 12. Check the correctness of this. So obviously, the formula to represent the general term, we know that Tn is an squared plus bn plus c, which means Tn is a. N squared, the b is 4n, and the c is minus 12. That's the answer. And that is the answer. So Tn is n squared plus 4n minus 12. Okay, now, which term of the pattern has a value of 128? Okay, so we look at the next question. So, I mean, if we already know that Tn is this one, which is n squared plus 4n minus 12. N squared plus 4n minus 12. And which term of the pattern is the value of 128? So there's a term that is the value of 128, but we know that Tn is n squared plus 4n minus 12. So that this is actually n squared plus 4n minus 12 equals 128. Equals exactly 128. So, okay, right? We move everything across. The cosine, we collect like terms. So it's n squared plus 4n minus 12 minus 128 minus 30, 40, 140 equals 0. Okay. Okay, what are the factors of this? This is n minus 10, n minus 10, n plus 14 equals 0, which means that n is 10 or n is minus 14. But obviously, I mean, at this point, you'd have therefore that this is n is minus 14. But you see, these are the number of terms. So the number of terms cannot be negative. They can't say count the people in a classroom and you say there are negative 14 learners in the class. So there can only be a positive number of people, a positive number of items, provided obviously that will be a loss in terms of profits. Okay, if now one is to calculate profit and say the profit is a negative, it's a loss. So it's not a gain, it's a loss. But now, obviously, which term of the pattern has a value of 128? The term is the 10th term. 10th term. Now, in 3.1.3, determine between which successive terms in the quadratic number pattern will the first difference be 599. So you continue. Right, determine between which successive terms in the quadratic pattern will the first difference be 599. Let's look at that. So we're dealing with the first differences in now. If this is minus 709 together with 20, 0 minus that is 7, 9 minus 0 is a 9, 20 minus 9 is 11. Find the differences. 9 minus 7 it's 2, 11 minus 9 is also 2. The first difference is the examiner is speaking about is saying, determine between which successive terms in the quadratic number pattern will the first difference be 599. So these are the first differences, 7, 9, 11. So now, if you write them out and we then say, what is the difference between them? So you'll see that the common difference you're getting is 2. Getting the common difference of 2, and now you're getting that the Tn is a plus n minus 1 times d. Okay, the first difference is always from what we call an arithmetic sequence. The first difference is from an arithmetic sequence, so that Tn equals, the first term of that is actually 7 plus n minus 1. The common difference becomes 2, in which case you have Tn equals 7 plus twice n minus 2, and this is Tn equals. So always the first difference is from an arithmetic sequence, but note that the first difference is from a quadratic number pattern. So quadratic number pattern means you must find the first and the second differences. So at this point, this one is twice n, and the 7 minus 2 is the 5. Okay, but we're not done yet, because we need to determine between which successive terms in the quadratic number pattern, will the first difference be 599? Okay, the first difference is 599. So you're going to make this to be 599. So Tn plus 5 is 599. 2n equals 599 minus 5, which is 594. Okay, if this is 594, you divide by 2. So you have 2n equals 594 divided by 2. Okay, what is 594 divided by 2? 297. The difference will be between term number 297 and so the difference, right? So the difference, the difference will be between 297 and 298. So the difference will be between term number 297 and 298. The difference will be between term number 297 because you're getting n equals 297. So the difference between term number 297 and 298. Move to the next point. Next point. Right, so in the next question, given the quadratic pattern, which is 5, 12, 29, they've already said it's quadratic. Write down the next term of the pattern. Right, to write down the next term of the pattern, you need to note a couple of things. You need to play around with the pattern. So if it's 5, 12, 29, 56. Okay, find the difference here. 12 minus 5, it's a 7. 29 minus 12, it's 17. 56 minus 56 minus 29, you get it 27. Okay, this one minus that, 17 minus 7 is a 10. 27 minus 17 is a 10. 10. You add these, you get 27. You add these, you get 37. You add these, you get 47. You add this, you get that. You add 12 and 17, you get 29. You add 29 and 27, you get 56. 56 and 37 will give you what? Okay, 50 and 30 gives you 80, and then this is going to give you a 90, 93. 93. So write down the next term of the pattern. It is exactly 93 there. To show that the first differences of this pattern will always be odd values. So now, okay, we're dealing with the first differences. We've already seen the first differences. Okay, oh, by the way, this is a new pattern. So, right, dealing with the first differences. These are the first differences. The first differences, you use the arithmetic sequence formula. The first term is 7 plus n minus 1. The common difference is going to be 10. 7 plus 10n minus 10. Okay, now you have 7 minus 10. This is 10n minus 10 minus 7 minus 10 is a minus 3. Okay. It's a minus 3. So we must show that this one is odd, actually. So that now we need to show, therefore, that the first difference of this pattern will always be odd values. Let's show that this number is an odd number. We play around with it. 10n minus 3 is the formula we got. Tn, therefore, is 10n minus 2 minus 1. Okay, minus 2 minus 1 is minus 3. It's a tricky question, but you need to reason logically here. Highest common factor of the two. Highest common factor of the two. What is the highest common factor of the two? Take out the 2, and then you have 5n minus 1, like that. Okay. Now, at this point, we're able to note thus 2 into 5n minus 1. This one, because 2 is even for any value of n. Tn is odd when Tn equals 10n minus 2 minus 1. 10n minus 2 minus 10n minus 2 minus 1. That's what we're saying here. Okay, let's analyze this because it's a tricky question, very creative from the examiner. But now, show that the first differences of this pattern always be odd values. Okay, the formula for the first differences is 10n minus 3 equals Tn. We're to show that just this guy here, the right-hand side is odd always. So now, odd numbers in mathematics are the numbers that are 2n minus 1. So you must show that this is an even number minus 1. So I must show that this one is even. So the minus 3 was written as minus 2 minus 1, and 2 was factored out so that we have 5n minus 1 minus 1. And then now the 2n is even for any value of n. Tn is odd when Tn is this. So it is indeed odd, and therefore we'll always have odd values. So yeah, look at the examiners. Sometimes they're out to get you. So you need to make sure that you are also ready for war. Okay, no, we already solved this one. Okay, let's deal with this one now. There's a linear pattern. What is a linear pattern? The word linear pattern suggests an arithmetic pattern. Suggests an arithmetic pattern. Okay, if it is an arithmetic pattern, calculate the value of p. We have 1 minus p, 2p minus 3, p plus 5. So you have this one. 2p minus into minus p is 3p. Minus 3 minus 1 is minus 4. We have p minus 2p, which is minus p. 5 plus 3 is 8. Okay. So now you have minus 3p minus 3p, which is minus 4p. 8 plus 4 is a 12. Okay. Yeah, you can go to that extent, but no need. Remember that this is already arithmetic. So since arithmetic, then the first differences themselves are common. So this is equal to this. So that we have the 3p plus p, which gives you 4p, which equals 8 plus 4, giving 12. 4p out of 4 equals 12 out of 4. P equals 3. Okay, yeah, P is 3. Write down the value of the first term of the pattern. So the value of the first term is 1 minus P, 1 minus 3, and minus 3 is minus 2. That is the first term. And this first term, you can write it as term 1 equals that. So that term subscript 1 equals, or T subscript 1 equals minus 2 there. Okay, so something that you can take note of there. Okay, let's look at the next question. In the next case, we want to write down the value of the common difference. So what is the common difference? Right, the common difference itself can be seen in a couple of ways, but it is the difference you get. So you can be able to get it in many ways. The common difference is the difference between successive terms of the linear pattern, or what we call the arithmetic pattern, the arithmetic number pattern, in which case, therefore, you can find the common difference as follows. Say, for instance, what is the second term? What is the first term? We have seen, therefore, that the first term here is the following. Right, we've seen that at this point, the first term. Right, the first term is minus 2, and then we need the second term. What is the second term? The second term is 2p minus 3, which is 2p minus 3, which is 2. The p is 3 minus 3, which is 6 minus 3, which is 3. Okay, that is the second term. So the common difference is T2 minus T1. What is T2? Is 3 minus T1, which is 5. Which is exactly 5. So obviously they wanted the common difference. The common difference in the arithmetic or linear patterns, we find it by using the successive differences, and therefore we can see that the common difference becomes a 5 there. Okay, now there's something else. Then explain why none of the numbers in this linear pattern are perfect numbers. Explain why none of the numbers in this linear pattern are perfect numbers. So to explain why none of the numbers are perfect numbers, we actually solve that question for pen 3. Right, so perfect numbers themselves, once again, what? And we analyze that. But first, we explore the pattern here and say it's 1 minus p, 2p minus that, p plus 5. Okay, p is it's a 3. So you have 1 minus 3 here. You have 2p. Okay, p is a 3 as well. So, which is 3 minus 3, and then this one is 3 plus 5. 1 minus 3 is minus 2. 6 minus 3 is a 3. 3 plus 5 is an 8. Okay, let us continue now, because we've already seen that the common difference here is what? The common difference is 5. So if you have minus 3, minus 2, you add 5 to it, you get 3. 3 plus 5, you get 8. The next one is going to be 8 plus 5, you get 13. You add a 5 to 13, you get 18. You add a 5 to 18, you get 23. You get 28, and so on and so forth. That is exploring the pattern. But what then is the meaning of all this here? And how, therefore, can we explain that none of the numbers in this pattern are perfect numbers? Now, all the terms are except T1 and sorry. Now we know that as part of the solutions, as the solution here, we say all the terms, with exception, right? So all the terms except, right? All the terms except T1 end in either a 3 or an 8. While perfect squares end in 0, 1, 4, 5, 6, 9. Okay, so that is something that becomes very important. So let's spend some time to analyze this and then say, explain why none of the numbers in this linear pattern are perfect numbers. Okay, they end in, this one ends in 3, in 8, in 3, 8. Yet now, perfect numbers end in 4, for example, the number 4, or 25 ends in the number 5, and this is a perfect number because the number 25 is a perfect number, what they call a perfect square. Okay, and also they end in 6 because you're going to have the number 16 is a perfect square because it is 4 squared, and therefore 4 squared ends in 16. But now, since this one's end in 3, 8, 3, 8, etc., you can see the pattern is very clear that this is a pattern of non-perfect numbers. So we have to explain why none of the numbers in this pattern are perfect numbers. So to always explain patterns, you need to explore, write a bit more terms always in the exam to make sure that you can see the pattern and be able to make your conclusion and deductions. Now, in the next point, we answer the following question. And in answering the following question, we're looking at more graphs. Now let's look at graphs and functions very quickly. Right, f of x equals x squared plus bx plus c is called a parabola with a not 0, and g of x equals 6x plus k are drawn below. We can see the graphs there, the parabola in a straight line. Point D is a common point on F and G. This one is a common point on F and G. F intersects the x-axis at -3 and 0, and the other one is 2 and 0. G intercepts the graph of F at D only. There they intersected D only. There it is. For which values of x is F negative or 0? For which value of x is F negative or 0? Right, obviously now we are looking at where the function is negative or 0. The function is positive here. The function is negative here. The function is positive here. Okay, we're dealing with the parabola. So for each value of x is negative, it is negative between x equal to -3 and x equals 2. So which means that -3 less or equal to x less or equal to 2. Determine the values of a, b, and c. Next question. Right, to find the values of a, b, and c, we are, okay, obviously this brings us to a very important discussion you need to have in terms of the values of a, b, and c that you need to get. But also, if we're given the x-intercept, so we use the formula ax minus x1, and then we use x minus x2. Right, we're going to use this one, and this one is an x1, which is -3, and x2 is exactly 2. So you can have x -3 here, and then x -2 there. Okay, which means you have y equals x plus 3 here, and x -2 there. All right, so we good. Okay, it passes through this, and then what do we have? Okay, we need just an extra point, and this parabola graph, we say it passes through another point. It passes through the point 1 minus 8. So that in the end, then y is -8. Our x is 1 plus 3, 1 minus 2. So this is -8 equals 1 plus 3 is actually a 4 times -1, which is -4a. We divide by -4, we divide by -4, so that a is equal to 2. Okay. Okay, yeah. Okay, if a is equal to 2, then you just, okay, remember we need to get the values of a, b, and c. They love this in the exam. Okay, so your a is 2, so you plug it in here, and that gives you 2, and then gives you x plus 3, and it gives you x minus 2, and y is therefore the same as 2, and this is x squared minus 2x plus 3x, which is x squared, x by x, and then plus x, and then this is -6. So 2x squared plus 2x minus 12. Okay, yeah. Okay. B equals C equals -12. Determine the coordinates of the turning point of F. Yeah, the turning point. We found the values of A, B, and C. A is 2, B is 2, and C is -12. Determine the coordinates of the turning point. So, right, so to find the coordinates of the turning point is very easy. In 5.3 now, you already know that y is 2x squared plus 2x minus what? -12. X, for the coordinates of the turning point, we use two formulas, and we're going to explain these two formulas. So they are very important for us at grade 11. So this is minus b over twice a, which is -2 over 2 times 2, which is -2 over 4, which is -1/2. This one is called the axis of symmetry. It's called the axis of symmetry. Okay, now, okay, this is called the axis of symmetry, but what do we do with this? Okay. called the axis of symmetry. Okay, now the y formula is 4ac minus b squared all over 4a. And this is 4a is 2, c is minus 12, minus 2 squared over 4a. 4 times 2 is what? It's 8. 8 by 3, 8 by 6 in that. Okay, so what is this? 4 by 12. 2 by 12 is 24, 48, 96. And the 4 would give us... Okay, the bottom is going to be 4 times 2, giving us an 8. And the top here, it's going to be exactly, you can pull out the 4 here. Okay, this is 4, and this is 2 squared, which is 4. Pull out the 4. 2 by minus 2 by 12, which is minus 24. Minus 1 is minus 25. Minus 25 by 4 is actually a minus 100. Divide by 4. Okay. You get minus 25. Divide by 4, and 4 goes how many times here? It goes 2 times. And this is minus 12, remainder 1 out of 2. So yeah, when it comes to the turning points of the parabola, you can use these two formulas. The x equals minus b over 2a is for the axis of symmetry, and the other one is for the y ordinate. So in other words, this one allows us to then say the turning point here has two particular components. You have the x equals minus 1/2, and the y equals minus 25 out of 2. And obviously, the 25 out of 2 is the same as minus 12, remainder 1 out of 2. This one is called the ordinate, and this one is called the abscissa. Okay, now this is exactly what you have here. But right, so we found the coordinates of the turning points, but you can find the coordinates of the turning points differently. So you can take this x value here and substitute into the original function. So you substitute into the y equals 2x squared plus 2x minus 12. You can come here and then say 2. What is our x? Our x is actually minus 1/2. You square that. Minus 1/2. And what is the answer? What is the answer? So this is actually minus 12. Minus 12 and 1/2. And that's the answer. So you have to determine the coordinate of turning point of F, and that is what we have here. Okay. All right, so you can use two methods to find the y value of the turning point. Substitute into the formula 4ac minus b squared over 4a, or use the other one there. Okay, we continue. Write down the equation of the axial symmetry of h if h is this one here. So now there is a new transformation of a function where it's x minus 7. So if somebody writes this one as h, which is f of x minus 7 plus 2, what does it mean? It means that we have 7 units to the right. Okay, 7 units to the right is a transformation. So if this one here is minus that 7 units to the right, it means you have 7 plus 1/2, and therefore that is what you're gonna have. 7 and 1/2. So obviously this was at minus 1/2. Right, it's at minus 1/2, and then now you're gonna translate the graph 7 units. So obviously, what then you're gonna have, because you need to write down the equation of the axis of symmetry of H, if this is the case. So if this is gonna be translated 7 units to the right, so this is minus 1/2, and then at this point, this is 1/2. So this is actually 1 unit. And then it would have moved 1 unit here to This one, so if it's going to move, for instance, 6 more units, it would therefore be what is required. So at this point, let's just do this carefully. So we can do it on a number line here. Minus 1/2, 1/2, okay, 0, 1/2, 1, and then there's 1.5, 2, 2.5, 3, 3.5, 4. Just trying to do it carefully. 4.5, 5, 5.5, 6, 6.5, 7, 7.5, 8. Okay, let's do it. So now we are at minus 1/2 here, and you want to count. So you count 7 units. So now you would move from here. This is 1/2, and this is 1/2. So up to here, it would have moved 1 unit here. 1 unit, and then now, if you come here, you move from here, you move to there. Yeah, it's a movement by actually 2 units. And you can see the movement by 2 units is actually such that it is 2 minus 0.5. So you can actually already see that it's going to be exactly 7 minus 1/2 there. And this is going to be exactly 6 and 1/2, or you can say 6.5. You can continue with the pattern over there. Write down the equation of lexisymmetry of H if that is the case here, which is exactly 6 and 1/2. And obviously that's lexisymmetry. Determine the equation of a line Q which is perpendicular to G passing through the point minus 3 and 0 in the form y equals mx plus c. Determine the equation of a line Q which is perpendicular to G. Okay, let's do it on the next board here. Right, you need to determine the equation of a line Q which is perpendicular to G. Right, obviously this is F and that is G. You need to find the equation of a line Q which is perpendicular to G passing through the point minus 3 and 0 in that form. Okay, line perpendicular to G, you already know this one. The G and G has the equation, this one, G at x equals 6x plus k. So you come here. G at x equals 6x plus k. And this gives us actually the gradient of G, which is 6. So if you look at the gradient of the gradient of a line perpendicular to G, it must be -1 because the line perpendicular is actually perpendicular to G. So there is a line perpendicular to G. A line perpendicular, which is indeed perpendicular to G. Okay, right. Now, what is the gradient of the perpendicular? Because the gradient of G is clearly 6. And this is clearly 6. And this is equal to -1. And obviously we perform division, so the gradient of the perpendicular is -1 out of 6. Pay attention because now I want to find the equation of a line which is perpendicular to G passing through the point -3, 1, 0. So this is -3 that xy. Right, so now it passes through this. Okay, if it passes through that, we have y minus y1 equals m into x minus x1. Okay, pay attention. Y minus 0. The gradient is -1 over 6x minus x1 is -3. Y equals -1 over 6x plus 3, which is -3 out of 6. Y equals -1 over 6 minus 1 out of 2. So, yeah, what is the equation of the line that the examiner wants? So, effectively, this examiner wants the line y equals -1/6x minus 1/2. That's the answer. Let's look at the next question. The next question is about the exponentials. Let's deal with the exponentials, but also let's deal with the vertex form of a parabola. Right, this is what you call the vertex form of a parabola. Sketch the graphs of P and H. P and H are on the same set of axes in your answer book. Indicate all intersected axes and turning points. Let's sketch very quickly. This is the y-axis and this remains our x-axis. And this is P of x equals 4 to the power x. H is this. Okay, if this one is an increasing exponential function. It is an increasing exponential function to 4 to the power x, meaning that when x increases, y increases. So pay attention to this. Right, so now if this is the case, when x is 0, okay, this one is the vertex. And now we need to deal with this one here. This to deal exactly with this. The vertex is at 1 and minus 8. When x is 1 and y is minus 8. Okay. If you want to find the x-intercepts, you let y be 0. So that 2 of x minus 1 squared minus 8 equals 0. Which means x minus 1 squared equals 8 out of 2, which means x minus 1 squared is 4. Okay, let's continue with this. Okay, if x minus 1 is 4, then we have x minus 1. You put the square root here. X minus 1 is plus or minus 2, which means x is 2 plus 1, or x is minus 2 plus 1, and x is 3, or x is minus 1. Okay, this is going to give us the x-intercepts, and the x-intercepts are going to occur when x is 3, y is 0, x is minus 1, y is 0. So this would be exactly what we have here. Okay, so you need to note the fact, therefore, that it's going to be x is going to be minus 1 and y is going to be 3. And now when x is 0, you're going to get the y-intercept. You let x be 0. H of 0 is 2, 0 minus 1 squared minus 8. Which is 2 minus 8. 2 minus 8 is a minus 6. Meaning it's going to cut it minus 6 here. Let me just do it in green color. So there's a graph that's going to be like this. Okay. And then now, this is the graph that you have of H, this one, and this one is the graph of P. Right, so obviously here, this one, when x is 0, y is 1. Get the graph of f of x if f of x is p of minus x using the same axis as in the question. So if you have this one where you have f of x equals p of minus x, that would be f of x equals p of minus x, which is f of minus x. Okay, f of minus x, this one becomes a decreasing function. So if the power is negative, the graph is going to start from the left and proceed to the right. This new graph that we've just got here is nothing other than the graph of the p of x function. Is the graph of the p of x function, and the graph of the p of x function is as follows. So it is actually, yeah, it is f of x equals p of minus x. Hello, my dear.
Yeah,
Yes, fine. Thanks, and you, my dear.
ngiyaphila sir. Bengithi kusitshela usibuyile le.
Oh, all right. Danke, my dear.
Ngene ngabo 5.
Oh, all right. Okay. Okay. Siyabonga kakhulu, my dear. We keep in touch then, my dear.
Okay.
Okay. Thanks, my dear. Have a good night.
Bye.
Okay. Bye, my dear. So f of x equals p of minus x here, and the p of minus x is 4 to the minus x like this. Okay, that's what we have. That's 4 to the minus x. Like that. That's 4 to the minus x, just like that. So in the end, then we have this graph here. We have this graph here. Okay, it doesn't touch the horizontal axis, but it gets as close as possible to horizontal, but doesn't touch it. So yeah, these are the graphs we're gonna have there. Right, these are the graphs we're gonna have. Next question. Okay, the graph of h is shifted 2 units to the left. Write down the equation of the new graph. Right, so the graph of h is shifted 2 units to the left. Is 2 into x minus 1 squared minus 8. But it is shifted 2 units to the left. Write down the equation. So 2 units to the left. What happens then? How does the graph look like there? Right, so 2 units to the left. The new graph is going to be obtained as follows. Okay, so let's look at the graph of h. Because if it's 2 units right, you subtract. So to the left, you add. To the left, you add. So if they say left, you add 2 because it's 2 units. But if it was right, then you're gonna minus 2. But here it's to the left 2, so you add 2. And then it becomes x, and then you add 2 to x. You add 2 to x, but there's a minus 1, you square that is minus 8. H of x plus 2, like this. Okay, 2 units left. And this is the graph. So now you'd find in 6.3, therefore, that your y is 2x plus 1 squared minus 8. Okay. And immediately at the point that you're adding, you can just say y is equal to this, y equals this, and y equals that. 6.4. Right, in 6.4, show algebraically that this is the case. But you remember that p of x is 4 to the power x. And then now the examiner is saying, find this. Wherever there is x, you replace in the exponential function by x plus 1, which is this, that. Okay, you can split it like that. This 4 to the power 1/2 is a square root of 4. Square root of 4 is 2. 4 to the power x. So 4 to the power x is p of x. And therefore, we can conclude that x plus 1/2 is actually 2p of x. Next question. So let's look at this graphs quickly. Determine the values of a, p, and q. So there's something called the rectangular hyperbola, which is this kind of a graph. So to find this now, you need to realize that this is x equal to this, and this is y equals this. So if you want to find these, the p and the q, so you need to say x is 4, which means x minus 4 is 0. Look at this guy. That is our p, so p is 4. Y is this, and this always gives us the q, so our q is 2. Our q is 2. And then now, okay, if this is the case, you have f of x equals, what is our a? Okay, our A we don't know, but we know our P is 4, Q is 2, but it is through. It is through T with coordinates 5 and 3, which means it's X and Y. So our Y is 3, our X is 5 minus 1. 5 minus 1 is A out of 4, plus 2 multiplied through by 4. 4 by 3, it's 12. 12A, 4 by 2 gives us 8. A is therefore 12 minus 8. 12 minus 8 is a 4. Right. Okay, let's see now. Okay, this is a 4. X minus 4. And you have X minus 4 there. So that here you have 5 minus 4, which is a 1. Which is A is 1. Okay, obviously they asked us to find a value. So we're able to see that A is 1. P is 4. Q equals 2. Q equals 2. So we find the next thing. So write down the equation for h of x if h is the graph of this. If h is the graph of f where a is negative. Write down an equation for h. Right, so if h is the graph of f where a is negative, so right, just making a negative. We remember that f is 1 over x minus 4 plus 2. So when a is negative, write down the equation for h. When a is negative, so it's going to be minus 1 over that. Okay, so let's just write clear here. So that's going to be minus 1 over the x minus 4 plus 2. All right, so now next question, we're looking at this one. All right, write down the range of f. Write down the range of f. Right, to write down the range of f, a couple of things. Okay, here is f. Where is f? Is this one? And we want its range, right? To write the range of f, we note that the range is all the real numbers, but y is not 2. That is the range. So for the range is the same as the domain. They asked for the domain. They did not ask us to find the domain, but to find the domain of this graph, you need to say x is an element of R, but x is not 4. That is the domain. The range is that. Okay, if the graph of f is reflected, if the graph of f is reflected in the line y equals minus x plus c, the new graph coincides with y equals f of x, determine the value of c. Okay, yeah, the value of c is nothing other than the because this, so it passes through. This is a line of symmetry. If you perform a reflection and the new graph coincides with the old one, it means that you have a line of symmetry. So the line of symmetry passes through x equals 4 and 2. So which therefore means it passes through x equals 4 and 2, y equals minus x plus c, xy, 2 minus 4 plus c, c is 6. Y equals minus x plus 6. Okay. So obviously calculate the value of C. So the value of C is exactly 6 there. Right. Okay, so we're done with paper 1. Please allow me to, I need to end this recording so that I can separate paper 1 and paper 2. So I need to send another link for the continuation of paper 2 because now is 9:40 p.m. at night. But I need to separate paper 1 and paper 2 so that my recordings can be separated because I can't just continue because the paper 2 is this one. It's paper 2, but I can't just jump to the paper because then the recording is going to be continuous. It's going to be difficult for me to separate the 2 videos. So to make it easier, I need to send another link. Please allow me to send another link on the group, and then you shall join again, and we shall have a discussion on paper 2 just now. Okay, so I'm gonna end this recording. Please join again in the next split second.